Okay. Thank you. That's it. Right. Hi, Dr. Memari again. Today we are going to perform the experiment 9 for you. The purpose of performing the experiment is to make sure you have the data to collect and record your observation in order to complete your data sheet for the experiment. Experiment 9 and turn in to your professor, either is me or another professor teaching the lab. Why are we doing this experiment? When we perform this experiment, you are going to learn about few things. There are few purposes for performing this experiment. First one would be studying law for conservation of mass. Basically, we start with copper. We change the copper to copper nitrate to copper hydroxide to copper oxide to copper sulfate. Then from copper sulfate, we are going to get back to copper. Ideally, if we start with 0.5 grams of copper, we should end up with 0.5 grams of copper if we don't lose the copper in any step. The second purpose of this experiment is to learn about different types of reaction, whether it's like oxidation reduction type reaction. You have copper 0. Oxidation number for copper is 0 in solid form. When it changes to copper 2+, is basically actually being oxidized, and oxygen is being reduced here. So we have double displacement reaction. We have single displacement reaction, like this one, single displacement reaction. You have acid-base reaction. You have decomposition reaction. So you are going to learn about different type of reaction, and you are going to cycle the copper through set of these reactions. By doing that, you learn about lab techniques, and you learn about different type of reactions. Also study the law for conservation of mass. So I'm going to start with the procedure for this experiment. The first part of this experiment, let me stop sharing the document so you could get full screen of the video what is presented here. I'm going to press here. I'm just going to set here the mass of, unless the mass of beaker is a question, because I always have to be careful with the data sheet. What do you need? So is the mass of empty beaker. So I have to give the mass for empty beaker to you. So the mass for empty beaker here is 107.114. This is the mass of empty beaker. Yeah. Mass for empty beaker. Okay. Then we add 0.5 grams of copper. 0.5 grams of copper, about 0.5. 114,614. Okay. 107.614 grams mass of beaker copper. So you get the mass of the copper by difference. So it's going to be 0.5 gram copper. 0.5 grams of copper. And the next step, we are going to add nitric acid, and I'm going to have to do this part of the experiment inside the fume hood, and you record your observation. You're going to add 5 milliliters of concentrated nitric acid. Nitric acid is the only acid that can actually dissolve copper or react with copper. So if you see from there, the brown color gas is coming out. I hold it up to you. It's a very toxic gas. It has to be done in the fume hood. The fume hood is not acting strong to me at this point. Otherwise, it should have just pulled up. So we have that brown color gas. We're going to leave it there, make it stay there until that reaction is complete, because we don't want to bring the beaker out and get the gas, toxic gas, inhale the toxic gas. I use 100 milliliter gas cylinder. Oh, I have 50 here. Okay. Okay, it's dissolved. So next step, adding water. 100 milliliters of DI water, because I have 50 ml graduate cylinder, so I'm just going to add 2 of the 50 to make it 100 milliliters of DI water. The brown gas is gone, so I can now show it to you. Blue color solution. We had copper plus nitric acid. That gives this blue color solution. It's all clear. Next step, we are adding 30 milliliters of sodium hydroxide, 3 molar sodium hydroxide. And I want you to record the observation, what is happening. By adding sodium hydroxide to the copper nitrate solution, see the color change is a darker color. At the same time, it turns cloudy. And what is turning cloudy is actually insoluble copper hydroxide precipitate. So copper hydroxide form, and it gives that precipitate to you. Next step, and at this point, I mean, you need to follow the procedure to look for the steps. I hope that you already have your lab manual, because you need to have your lab manual in order to write the procedures or to read the procedures. For the next step, we are going to heat up the solution. We heat up the solution. I'm going to use a hot plate. You could use hot plate or Bunsen burner. Either one would work. I'm using the hot plate. Occasionally, I will mix and stir the solution. How long I'm going to heat it up is until the shade of the blue color goes away and it turns to black color. So black color basically is the copper oxide precipitate. So we're changing from copper hydroxide to copper oxide. So when we have the copper oxide solution, we would continue for the next step of the reaction. At that point, actually, I have to let it stay after we have the copper oxide. I have to let the mixture stand for a while for it to settle down, and then we do decanting. Decanting is one of the techniques that we it in experiment 3. What is decanting? Let's say you have a mixture of solid and liquid. We've done this technique before, we've used it in the past. When you have a mixture of solid and liquid in one beaker, then you have two ways to separate the solid from the liquid. Either you set up filtration apparatus, which we are going to practice today, filtration with gravity filtration, also with different step of the experiment. The other method would be decanting. So you let it settle down, you have the clear liquid on top, and you have a cloudy or more condensed and dense part of the mixture at the bottom. Then you are going to pour off the clear liquid without getting any of the solid into the receiving container. The beaker is going to be. You hold your stirring rod with a 45-degree angle against the tip of this designed area of the beaker. Has this designed transferring part of the beaker. So when you are transferring, you basically transfer from here, not from this side, because this side is going to give like more of a backsplash, but here is easier to transfer. So then you would pour it over the stirring rod while you are holding with 45-degree angle. Only the clear portion on top without getting any of the solid into the other beaker for methods for separation. That's why I said that earlier. We are going to learn about some techniques when we perform this experiment. Because it's taking time for it to change the black color, the blue color goes away. I'm going to prepare the solution and the equipment that I need for the following steps. So I need to, at one step, I know I need to add sulfuric acid. So I'm going to go ahead and measure sulfuric acid. I look the quantity in the procedure and I measure about 20 milliliter, I think, but I will double check, of sulfuric acid. And also, I would need to measure zinc, about 2 grams of zinc for the experiment. So I'm going to do my measurements now, and I don't have to worry about it later. So going to add 15 milliliter of 6 molar. So I get the 15 milliliter of 6 molar sulfuric acid. I have my sulfuric acid ready for later when I'm doing when it's that part of the experiment. Basically, part 4 of the experiment, I need my sulfuric acid. For part 5 of the experiment, I need zinc. So I'm going to measure the zinc, but periodically I have to also mix the copper hydroxide precipitate, which is changing to copper oxide. I need 2 grams of zinc, so I'm going to measure. I'm measuring indirectly, so I may tear the mass of weighing paper and add 2 grams of zinc. I have 2 grams of zinc, also ready to go. What else do I need? For last step of this experiment, we are doing gravity filtration. For gravity filtration, we need ring stand, a receiving container. We need the iron ring. It should be small enough that when I place the funnel, it doesn't fall through because we have different sizes. To set up the height of the ring, it should be in that the stem of the funnel is inside the beaker. Because it is up high here, when I try to filter, this can move around and it can splash around away from the beaker. But when it's inside, if it accidentally, if it moves around, it's going to hit the container, hit the wall of the beaker, and as soon as it hits, it gives me a warning that be careful, you're splashing the solution out. So, filter paper is needed for gravity filtration. To prepare the filter paper, we're going to fold the filter paper in half, fold it again in half. We open one part in one side, 3 parts in the other side. So basically, we are making a paper funnel here. We're making paper funnel. We place that inside the glass funnel. For this procedure, we need to have the mass for filter paper for your data sheet. So I'm going to record the mass before I place in the funnel. Mass of the filter paper before filtration. Okay. 0.913 gram is the mass of filter paper. Before filtration. Okay. So I have the mass of the filter paper. Now I can actually place it in the funnel. When I try to place in the funnel, I'm going to show you how it acts. See, it's moving around, it's not staying still. In order to make it stay still, you can add 3 drops of water. You add 3 drops of water, you add 2 drops. It will make it wet and stays still. Okay. The color, the blue color is gone. We have black color precipitate now. I can stop the heat. Okay. Can stop the heat and let it stay. See, the blue color is gone completely. Let it stay. So this was the part 3 of the experiment that is done already. In part 3 of the experiment, we changed the copper hydroxide to copper oxide by applying heat to the mixture. And I don't want to disturb it. I tried to bring the camera closer for you to see the top layer, or you might see it from here because now it's getting more obvious. The top layer is clear and the bottom layer is more cloudy. The more time we give to this, we get better separation, and then we decant the top solution. In the top solution, we might have some extra sodium hydroxide now. We could have anything that is soluble other than the copper oxide. Everything that we added so far is going to be there. So we add the nitric acid to copper. We add sodium hydroxide. So it could be like sodium nitrate left over. We could have extra sodium hydroxide, or any soluble compound that is in this mixture is going to be in the top clear solution. The bottom part of the solution is going to contain, which is more cloudy, is going to contain the copper oxide. And that's what we need for our next step of the reaction. So we only need the copper oxide. So we try to get the top part out. I don't know. I usually wait until it's completely settled. But because we are recording for the purpose of just making the recording time less so you can get your data faster, I'm going to try to get some of these clear liquid out. And at any point, if I see I'm disturbing the bottom layer, I will stop. But right now, I'm just getting the top portion or the liquid out without disturbing the bottom portion. But the technique that is used in this experiment is actually decanting, like taking off the solution with the dropper is not wrong. It's okay. It's just it takes longer time. You're not using the technique per se, decanting, based on the procedure for decanting. Actually, the clear solution that I'm getting now is more clear than when we do this experiment with the students with decanting. I don't know, it's me that is doing the experiment, or it's the dropper that it doesn't cause any disturbance. Okay, so because we were going to do decanting, I have settled enough. I'm going to also use the decanting technique. So I'm holding the steering rod with a 45-degree angle. I'm only pouring the top portion, which is, if you can see from here, which is the clear solution without getting any of the solid in. So when I see the solid is going in, I stop and I can continue with some of the, oh, this is actually enough. Okay, enough. So to this solution, or to this mixture rather, not a solution, this mixture, trying to get as much clear solution out. So I changed my mind because I see a little bit more of a clear solution that there is really clear solution that I can get out. Okay, so this solution, I'm adding the sulfuric acid. So when I add the sulfuric acid, copper oxide is going to react with the sulfuric acid, and it forms a blue color solution. Now, this blue color solution is copper sulfate. Is different from the other solution, blue color solution we had earlier. That was the copper nitrate. So we have the copper sulfate now. With the copper sulfate, we are done with part 4 of the experiment, and we are going to do part 5 now from copper sulfate to recover the copper. To recover copper, we add the 2 grams of the zinc that I measured already into the copper sulfate solution and let it react. I have to show you the reaction that is taking place. Then I place it in the fume hood just in case if there is like hydrogen gas coming out too much, I don't want to inhale it. Zinc is gray color, and if you could see this powder that is down here, especially the flakes, they are reddish color. Those flakes that are forming now is the copper that is coming out of the solution. If you look at the color for blue color solution also, it's going to be fading out over the time. So we get less of the blue color. The blue color is coming from copper sulfate. Copper sulfate has blue color. When zinc goes into the solution, copper comes out. You don't have copper sulfate anymore. You have copper plus zinc sulfate. So the gas that is forming is a hydrogen gas. It bothers me. I'm going to place it in the fume hood. I place the reaction mixture in the fume hood to make sure that the reaction is complete before I take it out of the fume hood. There is no need for us to have hydrogen gas in the. Okay, I just want to show you those red color flakes that are forming because it's more obvious now, the color of the copper that is forming. You could record your observation. It has to stay in the fume hood so we don't get the hydrogen gas. So it has. The blue color is almost gone, and then we have the red color copper coming out. Just to make sure there's no more zinc left, zinc left over, I'm going to add some HCl. So HCl is not going to react with copper. It will only react with zinc. And filter it. So we are going to filter using gravity filtration that we set it up already. You want all the copper to stay on the filter paper. Any copper that is left in the beaker, I have to wash it with water. I got some water splashes here. Looks like we have a trip to Splash Mountain. Just a little bit, not much, but to clean up. After we wash with DI water, the procedure is asking us to wash with methanol and then wash with acetone. The purpose we're washing with acetone is to make sure that it would dry much faster, because acetone is the same ingredient you have for nail polish remover. If you leave it open, it evaporates, or when you apply it to your hand, it goes away quickly. It dries up quickly. So after washing with water, I'm washing with some methanol to remove any water, any impurities. And after washing with methanol, I'm going to wash with acetone. And when I wash with acetone, it's going to help drying to happen faster. So I try to wash the paper with acetone also, to make sure that the paper is washed with acetone as well. And wash with acetone. Okay, so we have the copper already filtered. If you look at your procedure, the next step or the last step is asking us to dry the filter. So we have to dry the filter paper with the copper. We dry the filter paper using a heating lamp. So plug in the heating lamp. It's on. I bring layers of filter paper so it absorbs the moisture from the bottom and the heat from the top. It will make the drying faster. There is no liquid left on the filter paper. I'm going to take it out. Take it out. Place it under the heating lamp. Turn on the heating lamp. And let the paper dry, because we need the mass of paper plus the copper. Copper dry because we don't want the copper to be wet. Because if the copper stays wet, when we measure the mass, it's going to be heavier than what we started with. Then you would think that I was alchemist and I actually created more copper than what I started with, and that is not possible. So ideally, we should get 100% or 0.5. No experiment is error-free. Always have some experimental error. Sometimes it's equipment, other times it's the person who's doing the experiment. So we do have personal error, we have experimental error. It adds up. So if we didn't get a 100%, it's okay. But 100% is ideal. If we get less than 0.5 gram, that means we lost the copper somewhere. When we were decanting, or we didn't add enough sodium hydroxide, not everything precipitated, or we lost it when we were washing, different steps. So if you watch the video, you can predict and find out in which step I was able to lose the copper, in what form. Either the precipitate did not form, or I lost it when I was decanting. If I get more than 100% recovery, if I get basically more than 0.5 grams, I'm just trying to see if the paper is wet or not. Still is wet. Okay, it's not crisp. If I get more than 100%, that means paper is still wet, or the copper still is wet. I didn't dry it well. Or it could mean that there was some zinc left over. And I added HCl to react with zinc to make sure that there is no zinc left over. That's supposed to be. That's what the procedure is calling for. But if I don't add enough HCl and some zinc is left, what I'm measuring the mass is the zinc plus the copper. And if it's zinc plus copper, obviously it's going to weigh more. So these are like hypothetical errors that can be contributing to the percent recovery. It can be higher than 100%, it could be lower than 100%, but the point is for you to understand how could you make it higher or lower. So in case if you were teaching someone to do this experiment, to perform this experiment, you could tell them, be careful not to do this, not to do that, because if you do this or that, you are going to get less than 100% or more than 100%, which none of them is good. Too much of either one is not good. There's always like acceptable range. Let's say if you have like plus minus 5%, for some experiments, then it's okay. But you cannot have 40% extra and say, well, I did everything the way that the procedure said. So that you just say, maybe I wasn't patient enough, I didn't wash it well, so there's some impurities, I didn't dry it well, maybe there is some solvent left. I'm waiting for the paper to be crisp. In that case, I know it's dry. So if I weigh now, I tell you what? Okay, paper looks dry, copper looks dry to me. I'm going to take it, and now we're going to go ahead and measure the mass for copper. The mass is 1.396. 1.396, sorry, 1.396 gram. That is the mass of filter paper plus recovered it's slightly less than what I expected. It should have been a little bit more to make it 100% recovery, but the solution, it wasn't completely white color. So maybe I lost some of the copper in the form of copper sulfate, because I didn't wait like long enough for the color to be like completely white color. It had a shade of a blue color. See this? It's not completely white. It has a shade of a blue color. It should have been white. So that small amount of copper loss, it could be because of that also. That's another step that you could lose copper if you don't wait long enough for the reaction of zinc to be completed with copper sulfate, because you're filtering or you're removing that liquid portion and discarding. We make sure everything is covered. We recover the recovered copper, we will discard it. And from your data sheet, yes, that's what you need after the filtration. And you finish your observation. There are a lot of questions about observation, so I hope that you did pay attention from the beginning of this video in order to record your observation and be able to fill out and answer questions in the data sheet. Thank you. I'm going to stop the recording. That's end of experiment 9.